my dear students. In the previous class, we were discussing about the chapter metals and non-metals. We have studied the reactions of metals with oxygen and the reaction of metals with water. In the today's session, we are going to discuss about the reaction of metals with acids. In the previous chapter, that is acids, bases and salts, you have studied that metals react with acid to form salt and hydrogen gas. Yes, we know that metals react with dilute acids like hydrochloric acid, sulfuric acid to form salt and hydrogen gas. But all the metals will not show the same reactivity towards the dilute acids. Different metals show different reactivity towards the dilute acids. Okay, let us check how do these metals react with acids. The metals, that is potassium, sodium, lithium, these are highly reactive towards the acids. Once they are put into the acids, the reaction is highly exothermic and it is very violent. So usually the reaction of these metals with acid is not carried out. Okay, the reaction is very violent and explosive. So the reaction of these metals are not carried out with acids. In this case also, these metals will react with dilute acid to form salt and hydrogen gas, but the reaction is highly exothermic, that it will be very violent and explosive. So the reaction of these metals are not carried out with the dilute acids. Potassium, sodium, lithium and also calcium also reacts violently with dilute acids. Okay, then let us see how do other metals will react with dilute acids. Take 4 test tubes here. Let us check the reactivity of the different metals with dilute hydrochloric acid. These are the 4 test tubes and take dilute hydrochloric acid in these test tubes. Okay, take dilute HCl in these test tubes. Now we are going to check the reaction of different metals with dilute acid. Okay, we are going to add iron, aluminium, zinc and magnesium into these test tubes. Okay, then we are going to check the reaction, how the reaction takes place and what are the products formed. All of these metals will react with dilute hydrochloric acid to form salt and hydrogen gas. There is a liberation of hydrogen gas. As these metals displace hydrogen gas from the dilute acid, there is a formation of bubbles of hydrogen gas here in all these cases. Now let us see how these reactions occur. Iron react with dilute hydrochloric acid to form iron chloride and hydrogen gas. Then aluminium react with dilute HCl to form aluminium chloride and hydrogen gas, and also zinc and magnesium also react. So all these metals react with dilute hydrochloric acid to form salt and hydrogen gas. As I have already said that there is a liberation of hydrogen gas, so you will observe the bubbles of that hydrogen gas here. And it is observed that not all the metals show same reactivity here. The rate of reaction is different for different metals. You can see here the rate of evolution of hydrogen gas, that is the rate of formation of bubbles of hydrogen, was more in case of magnesium and it was less in case of iron among these metals. So these metals have shown the order of reactivity as magnesium was more reactive than aluminium, which was more reactive than zinc, which was more reactive than iron. Among all these reactions, the most exothermic was with the metal magnesium, and also the rate of formation of bubbles of hydrogen gas was also more in case of magnesium. This shows that it will react more spontaneously and it shows more reactivity towards the dilute acid when compared to these. And this is the order that we have seen while carrying out the reaction. So in this way we will come to know that the different metals have different reactivity towards the dilute acid. And it was also same in case of sulfuric acid. When metals reacts with sulfuric acid, they form salt and hydrogen gas. For example, iron react with dilute sulfuric acid to form iron sulfate and hydrogen gas is liberated, and magnesium reacts with dilute H2SO4 to form magnesium sulfate and hydrogen gas is liberated. But it was seen that these metals will not produce hydrogen gas on reacting with nitric acid. Okay, when metals react with nitric acid, that is HNO3, hydrogen gas was not liberated. Why it is so? Why the hydrogen gas is not liberated during the reaction of metals with nitric acid? We know that nitric acid is a very strong oxidizing agent. HNO3, it is a strong oxidizing agent. What happens? The hydrogen which is formed during the reaction, it is oxidized to water when nitric acid is used in the reaction. And also nitric acid, it will reduces itself to the oxide of nitrogen like nitrogen dioxide or NO or HNO2 in this way. So it may be asked in your examination that why the metals will not produce hydrogen gas when they react with dilute nitric acid. Because it is the reason that nitric acid is a strong oxidizing agent. It will oxidize the hydrogen that is formed to water. Here also exception is there. Only two metals which are magnesium and manganese. These are the two metals which react with very dilute nitric acid to evolve hydrogen gas. Only these two metals react with very dilute nitric acid to evolve hydrogen gas. You should remember these exception. Okay, which are the only metals which react with nitric acid to evolve hydrogen. It is true that all the metals, means which metals we have seen here, will react with nitric acid, but they do not produce hydrogen during the reaction. But these are the only two metals which will liberate hydrogen during the reaction with nitric acid. Okay, then what about other metals like gold, copper, silver? Do they react with dilute acids? Actually, these metals will not dissolve in this dilute acid, so they will not form the reaction. If I make the reaction of copper with dilute HCl, it will not form any reaction. Keep in mind that all the metals will not displace hydrogen from the dilute acids. You have studied about the reactivity series, okay, in the previous chapter also. Those metals which are placed below those metals which are placed below the hydrogen, they will not displace hydrogen from the dilute acid. These metals are not soluble in dilute acids. Okay, keep in mind that copper will not form, it will not undergo reaction with dilute HCl or dilute H2SO4 to displace hydrogen. So if you take the test tube, in it if you have taken dilute HCl and you are going to add copper turnings into it, and whether you observe the reaction here, there is no evolution of hydrogen gas, there is no formation of bubbles of hydrogen gas, because the reaction not occurs in this case. Reaction not occurs here. Okay, we have learned that these metals like copper, gold, silver, platinum, these are not soluble in the dilute acids. So if we want to dissolve these acids, we have to prepare the special acid mixture, that is aqua regia. It is actually a Latin word which means royal water. It is a mixture of concentrated hydrochloric acid and concentrated nitric acid in the ratio of 3:1. So if ever you want to dissolve the metals like copper, gold, platinum, we need to prepare the fresh mixture of concentrated HCl and concentrated HNO3 in the ratio of 3:1. Where this mixture is used? In the purification of the gold and platinum, those gold and platinum materials are dissolved in the aqua regia for purification purpose. Okay. So overall, we have come to know that different metals have shown different reactivity towards the acids, and those metals which are above in the activity series, that is above the hydrogen, they will displace hydrogen from the dilute acids like dilute hydrochloric acid and dilute sulfuric acid, whereas these metals will not liberate hydrogen when they react with dilute nitric acid. Only two metals that liberate hydrogen on reacting with dilute nitric acid, they are magnesium and manganese. Okay, you should remember all these facts. And the metals which are placed below in the activity series, that is below hydrogen, they will not displace hydrogen from these acids. So copper, silver, gold, they will not react with dilute HCl or dilute sulfuric acid to form salt and hydrogen gas. Okay. Next, we are going to discuss about the reaction of metals with solution of other metals. We have seen this kind of reaction during the displacement reaction. Yes, that we have studied in the chapter 1. Then what has happened? The react metals has displaced other metals from its solution. What happens here? The reactive metals displaces metal from its solution. Suppose if you have taken metal A and you are going to react it with the solution of metal B, salt solution of metal B, what you are going to get? This metal A, which is more reactive than metal B, it is going to displace this metal B. It forms salt solution of A plus B. This B metal, which is less reactive than A, is being replaced by metal A. Let us see the examples here. Take a test tube. Take copper sulfate solution in this test tube. Okay. What is the color of copper sulfate solution? It will be blue in color. Yes. And then what you need to do is you should put a iron nail in it. Iron nail in the solution of copper sulfate. We know that here the copper is less reactive than iron. So what happens after some time? The reaction will turn. After some times, what happens here? The color of this copper sulfate solution, which was blue in color, fades. It becomes light in color. It is due to the formation of iron sulfate. And that nail which we have dipped in the solution is now coated with the brown material, brown coating on iron nail here. Why has it happened? What happens when you take copper sulfate solution and add iron to it? There, this iron will displace the copper from its solution to form iron sulfate, and there is a replacement of this copper. Means this copper will get deposited on the iron nail as it is being displaced by iron. Okay, this is the displacement reaction that is taking place. And these reactions occur only when this metal which you have taken is very reactive than copper or any other metal. Let us see few more examples here. Zinc reacts with iron sulfate solution to form zinc sulfate and iron. Here why is this compound formed? Because zinc is more reactive than iron. It displaces iron from its solution to form zinc sulfate and iron. So after observing all these reactions of metals with oxygen, water, acids and solution of other metals, a list of the metal has been made based on their reactivity. This list is completely based on the reactivity that is shown by the metals. And there was a series that has been developed which is in the decreasing order of the reactivity of the metals. This is highly reactive. The metal which is placed above, it is very highly reactive, and the metal which is placed at the bottom of this series, it is least reactive. As you go upward, the reactivity will increases. These metals are placed in the decreasing reactivities. Okay, and those metals which are placed above the hydrogen, they can displace hydrogen from the acids, and also those metals which are placed above the metals, and when you make it to react with the salt solution of those metals, the displacement reaction occurs. And if the metal is placed that is below in the series, it will not displace the other metal from its salt solution. Okay, see here, if you take copper and make it to react with iron sulfate, whether displacement occurs to form copper sulfate? No, the displacement will not take place here. Here, no reaction occurs because copper is less reactive than iron. You can see here, copper is here and iron is here. It is placed below the iron. So, it will not displace iron from its solution. So, while solving the equations, you should keep in mind the reactivity series. You should always remember these metals which are placed in the decreasing order of their reactivities. You should remember the order in which they are placed, so that it will be easier for you to complete the reaction. If they have given the reaction and you need to complete this, you should not write it as a displacement reaction. You should not write copper sulfate is formed here. No, the reaction will not take place, as copper is less reactive than iron in this way. Okay, let us see some of the questions on this part. What would you observe when zinc is added to a solution of iron sulfate? Write the chemical reaction that takes place. We know that zinc is a reactive metal. When compared to iron, it is more reactive than iron. So it displaces iron from iron sulfate to form zinc sulfate. Yes, zinc reacts with solution of iron sulfate to form zinc sulfate and iron. This is the reaction in bold. And you should also write the observation of this reaction. We know that ferrous sulfate, it is green in color. And after the reaction takes place, there is a formation of zinc sulfate. It is colorless. So when zinc reacts with iron sulfate, the green color of the solution will fades away and the gray color of iron is formed. The iron is gray in color. There is a deposition of this iron takes place after the reaction. Then the next question is, aluminium is used for making cooking utensil in spite of being highly reactive. We know that aluminium is a reactive metal. But what happens is, aluminium reacts with the oxygen present in air to form thin layer of aluminium oxide. And this layer of oxide is stable and it forms a protective layer on the aluminium, and it further resists the reaction of aluminium with external environment. Okay, aluminium reacts with oxygen present in air to form thin layer of aluminium oxide, and this oxide layer is stable and it forms the protective layer. Why? Because it prevents the further reaction of aluminium metal with the external environment. Okay, and prevents the further reaction of aluminium. So it prevents corrosion of aluminium and it can be safely used for cooking purposes. The utensils made of aluminium can be used safely because the aluminium reacts with oxygen present in air to form the thin layer of aluminium oxide, and this oxide layer is stable. It will act as a protective layer. Then that layer, the presence of that layer prevents the further reaction of aluminium with the external environment. Then the next question is, a copper plate was dipped into a solution of silver nitrate. After some time, a black layer is formed on the copper plate. State the reason for it. Write the chemical equation for the reaction involved. Copper plate was dipped into a solution of AgNO3. AgNO3 was taken and a copper plate was dipped in it. After some time, what happens? There is a formation of black layer on this copper plate. Why does this happen? Because copper has displaced silver from silver nitrate solution, because it is more reactive than silver, as we have seen in the reactivity series. Yes, let's write the equation for the reaction. Copper reacts with silver nitrate solution to form copper nitrate. Because of the formation of silver, a black layer is formed on the copper plate. So you have to write the chemical equation of the reaction, and also you should write that a black layer is formed on the copper plate. It is due to the formation of silver. Silver is getting deposited on the copper plate. Okay. The next question, why zinc oxide is called as an amphoteric oxide? We have studied that amphoteric oxides, these are oxides which react with both acids and bases to form salt and water. Means they behave both as acid and bases. Let us see the reaction of this zinc oxide with acid. What happens here? Also there is a formation of salt and water, and it also reacts with sodium hydroxide base to form salt and water. So zinc oxide react with both acids and bases to form salt and water. So it acts as an amphoteric oxide. You have to write zinc oxide reacts with both acids and bases to form salt and water. So it is called as an amphoteric oxide. Okay. Now we are going to discuss about the reaction of metals with non-metals. So far we have discussed about the reaction of metal with many other reagents. Now we have to understand the fact that these metals or elements which show reactivity with other elements, it is due to the reason that they always have a tendency to attain a complete filled valence shell. Yes, all the elements have a tendency to attain a completely filled valency shell. Okay, because of which we say that noble metals are unreactive, because they do have completely filled valence shell. When you take example of helium, neon, argon, krypton, these are all noble metals. Helium has duplet structure, duplet electronic configuration. It is exceptional case. And the other noble gases, they do have completely filled electronic shells. The last electronic shell is complete. That is called as valence shell. Okay. Neon has the valence shell complete, and also argon, it is also having the completely filled valence shell. Yes, as the last shell, that is valence shell, is completely filled, the noble gases, they are unreactive. Then when it comes to other elements, the valence shell is not complete, because of which all these elements always have a tendency to attain a completely filled valence shell. Let us have a look into the metals. Metals have, they have either 1, 2 or 3 electrons in their valence shell. Yes, metals have either they have 1, 2 or 3 electrons in their valence shell. So it is easy for them to lose those electrons in order to attain the completely filled valence shell. And non-metals, they have 5 or 6 or 7 electrons in their valence shell. So in order to be completely filled, they need electrons. If it is having 7 electrons, it will need one more electron to get the completely filled valence shell. In this way, these non-metals have always tendency to gain the electrons. Let us see the examples. For example, in case of metals, sodium, magnesium, aluminum, these are all metals. They have electronic configuration as 2, 8, 1, 2, 8, 2. It has 2, 8, 3. Yes, in case of non-metals, nitrogen has 5 electrons in its outermost shell, and oxygen, it has 6 electrons. For example, chlorine has 7 electrons in its outermost shell. You can see here the metals are having either 1, 2 or 3 electrons in its outermost shell. Suppose if these elements lose outermost electron, then they will get the inner shell completely filled. Yes, if it loses one electron here, then the last shell will become 8 in number, means it will have 8 electrons in it. And if this magnesium lose 2 electrons, the last shell will be L shell, and it will be having 8 electron in it. And aluminium, if it loses 3 electrons, then the last shell, it will be having 8 electrons. Yes, so always metals have tendency to lose the electrons in order to attain the completely filled valence shell configuration. Non-metals, you can see here, it has 5 electrons in its outermost shell. If it gains 3 more electrons, then it will become stable. And what about oxygen? It is having 6 electrons in its outermost shell. It needs still 2 more electrons in order to become stable. And in case of chlorine, you can see here, it needs one more electron in order to get its valence shell completely filled. Yes, so always these non-metals tend to gain electrons. They tend to gain electrons. Metals tend to lose electrons. Yes, so when these metals lose electron, it will be easier for non-metals to accept those electrons, and there is a formation of bond between those metals and non-metals. Let us see how does the formation of bond takes place when the metals and non-metal react with each other. Okay, let us take with the help of an example. Okay, let us take sodium as an example here. Sodium, the electronic configuration is 281. It has one electron in its outermost shell. And chlorine, it is having 7 electron in its outermost shell. You can easily see here, if sodium loses 1 electron, the last shell will be having 8 electrons and it will become stable. And in the case of chlorine, if it gets 1 electron, then its outermost shell will get completed. What happens here? Sodium loses 1 electron to form sodium cation. Okay, here sodium loses 1 electron to form sodium cation. Initially it was having 2, 8, 1 electrons. Now after losing 1 electron, now it is having 2, 8. The electronic configuration will be 2, 8. Overall, initially it was having 11 electrons. Now it is having 10 electrons. And we should remember that when the number of protons is equal to the number of electrons, then the charge on the atom will be 0. That means the atom will be neutral. But here you can see that initially it was having 11 electrons. Now it has 10 electrons, but the number of protons are, initially it was having 11 protons. Now also it is having 11 protons, but the number of electron has been reduced. So it will get the positive charge. Whenever an atom loses the electron, it will get positive charge. Okay. And what about chlorine here? Chlorine has tendency to gain electrons. It will gain electron from the sodium to form chloride anion. Okay. Its electronic configuration is 287, and after gaining electrons, it will get the electronic configuration as 288. Yes, now its outermost shell is completely filled. So the electron that is lost by the sodium is accepted by the chlorine. Now this is positive cation. Yes, it is anion. There is a force of attraction between the cation and anion. This electrostatic force of attraction results in the formation of a bond called as ionic bond. Now there is a formation of bond. There is an electronic force of attraction between sodium cation and chloride anion, resulting in the formation of bond between them. Let's see how the bonding takes place. Let me represent it with the help of octet structure. Let me represent it with the Lewis dot structure. This is sodium and this is chlorine, which has 7 electrons in its outermost shell, and sodium is having 1 electron in its outermost shell. As we have already learned that this sodium loses electron. Yes, it will loses electron to form sodium cation, and chlorine gains an electron to form chloride anion. This is sodium cation. Always the element which loses the electron is called as cation, and the element which gains electron, it will become anion. Okay, will be chloride anion. And now the electrostatic force of attraction between sodium cation and chloride anion results in the formation of sodium chloride. Sodium loses electron to become sodium cation, and chlorine gains electron from sodium to form chloride anion. So the electrostatic force of attraction between sodium cation and chloride anion results in the formation of bond between these two, cation and anion, to form sodium chloride. And note that this sodium chloride does not exist in the form of molecule, but it is surrounded by the oppositely charged ions. Means sodium cation is surrounded by the negatively charged chloride anions, and chloride anion is surrounded by the positively charged sodium cations. This is how ionic compounds are formed. Let us see one more example of formation of ionic compound, how the magnesium chloride is formed. Let us see formation of magnesium chloride. First, let us write the electronic configuration of magnesium and chlorine. Magnesium is having electronic configuration 2A2, which means it easily donates 2 electrons to form magnesium cation. Okay. Why it has got +2 charge here? As it has lost 2 electron, it has got plus charge. Why it has got tendency to lose electron? In order to attain the completely filled valence shell. Once it loses this electron, it will become the valence shell, so that it will be completely filled. Then what about chlorine? It is having configuration 287. It has tendency to gain the electron in order to become stable, in order to get completely filled valence shell. Now you can see here magnesium can donate 2 electrons, but chlorine needs only 1 electron to become stable. What happens is one magnesium cation will donate 2 electrons to 2 different chlorine atoms. Okay, so it is having 2 electrons in its outermost shell. Now it can donate its 2 electrons to the 2 different chlorine atoms. It can donate 1 electron to one chlorine atom, one electron to another chlorine atom to form ionic bond between them. Now after losing electron, it will become magnesium cation. Each chlorine will have one electron from magnesium, so that the formula will be MgCl2, as each magnesium atom has donated its one electron to two different chlorine atoms. So there is a force of attraction between these cation and anion. This is magnesium cation and this is chloride anion. Now what happens? There is a force of attraction between this magnesium cation and chloride anion to form the ionic bond between them, resulting in the formation of magnesium chloride. Yes, this is how the ionic compounds are formed. So how do you define the ionic compounds then? The compounds formed by the transfer of electron from metal to non-metal is called as ionic compound. The compounds formed by the transfer of electron from metal to non-metal are called ionic compound. And the bond formed between them is called as ionic bond. What is ionic bond? The force of, that is electrostatic force of attraction that holds together the cations and anions is called as ionic bond. And the compounds formed by the transfer of electron from metal to non-metal are called as ionic compounds. This is all about the formation of ionic compounds, and this topic is very important from the examination point of view. You should thoroughly go through this concept. Okay. In the next session, we will discuss about the different properties of ionic compounds and also about the extraction of metals.